and welcome to the section on core programming principles. And what are we talking about in this section? Well, here we will cover off the core principles of programming just overall. So these things that we're going to learn are fundamental and universal. They're not just applicable to R only, they're also the same in C, C++, Java, and pretty much any other programming language you can think of. And the reason why I decided to put this section in is because normally in R courses you are expected to learn about the very sophisticated things in R right away. So you're thrown into the deep end, you're told about vectors, matrices, data frames, and so on. Well, this course is different. We really want to take it step by step, and I thought that it will be a good idea to first learn the fundamentals of programming to get you accustomed to this way of thinking. So having said that, if you're already comfortable with programming and if you've learned other programming languages, then feel free to skip this section and move on to the R specifics starting from the next section. Otherwise, I look forward to seeing you on the first tutorial, and make sure to follow along with the code. That way you will learn much faster. And I'll see you on the first tutorial.
Hello and welcome to your very first tutorial on R programming. This is Kirill Eremenko and I am super excited to have you here. And today we're talking about the data types in R. Now, we are going to cover 5 main data types, which are also called the atomic data types in R. So let's get started right away. Okay, I've got my window, RStudio window open here, and at the top on the left, this is where we're going to write our code. So if you don't see this window or this part of the window here in the top left, for instance, it looks like this, you only see the console and these other 2 windows, then all you have to do is click this button up in the top left corner to create a new R script. So let's go ahead and do that, and now we have this new R script where we will be writing our code. Alright, so let's start with the integer data type. So I'm going to put a hashtag, and hashtag in R stands for comment. And why that is because I want to type in something that shouldn't affect the code and execution of the code. Now I'm going to go into my settings here, and I'm using a Mac here, but if you're using Windows, then everything should be quite similar. And we've already done the layout of our code, but what I want to do is I just want to increase the font size so we can see everything a bit better on the recording. So there we go. So I want to create an integer. I'm going to start by giving the variable name. The name is going to be x, and then I'm going to put triangle or bracket facing towards x, so kind of like a less than sign, and then a minus. So this creates an arrow. There we go. That's the arrow that we've created with these 2 symbols, and in R, this is the assignment operator, and I want to assign x the value of 2. So it'll be an integer of 2, but in R, and we'll get to this in a second, in order to make sure that this is going to be an integer, we have to put a capital L afterwards. Once again, we'll get back to that in a second. Let's just run this code for now. So in order to run this code, all you have to do is keep your cursor or keep this line selected. Basically, you see this vertical line blinking. That means I'm on this current line, and press Control Enter if you're on a Windows, or Command Return on a Mac. And as you can see, what happened is this code has been copied into the console and has been executed, and what we have now is a new variable in the global environment over here. So x, and the value is 2L. And now we're going to check what actual type does x have. And in order to check the type, all you have to do is type in type of, and then in brackets put in the value that you want to check. So let's execute that. So once again, I'm going to click Command Return on my Mac, and here this code now has been copied to the console, and now we can see that it is an integer. Alright, so we've created our first integer. Once again, we'll get back to this L in a second. Alright, let's have a look at the next type, which is the double type. And double just basically means anything with a decimal point. So we're going to say double here. So this is going to be our comment. So basically anything with a hashtag at the start is completely ignored. I know we're executing line by line, but still, if you want to save your file later and you don't want to get any warnings, then you should put hashtags before anything that shouldn't be looked at or that isn't part of your code. All right, so now we're going to create a double variable. So let's call it y, and then we'll put, once again, the assignment operator, and we'll give it a value of 2.5, so it has a decimal point. And once again, let's execute this line. Press command return on the Mac, and there you go. We've got this code was copied here and has been executed, as you can see. And right away, we've got a new variable here with a new value. And now let's have a look at the type of y. Type of y. All right, so let's execute this line now. As you can see, it has been copied over here. And executing that line, what the console returned was double. So now we have two variables. One is an integer and one is a double. Okay, so now we can discuss this L symbol. So why do we have to put an L? Why can't we just say X arrow 2? Well, the reason is because by default, R will decide for you how it should store the data. And all operations in R, all arithmetic operations are always conducted on a double level, because it makes sense, right? If you're going to add like a double variable, so something that has decimal points and something that doesn't have decimal points, then the result of the operation might actually have decimal points. So it's logical that any operations are conducted with numbers that have decimal points. So that's why it's better for R to store anything as double. So if you don't put an L here, so let's go here, let's delete that, and let's rerun this line. So we will basically override our existing variable X over here. So I'm going to press command return, and now this variable has been created again. And as you can see, it's X is just 2, not a 2L anymore. And now if we check type of X, you'll see that it's a double. So basically, R by default will store your integer variable, this single X variable, as a double, just because it is anticipating that you will require arithmetic operations in the future. So, and because they're going to be run in double mode anyway, it's just easier for R to store that variable like that right away. So if you know, for instance, that you're not going to be running arithmetic operations, and for example, this variable is just used as a category, or as you're giving sequences to something like it's a first, second, third, so you're never going to be adding them, or you're never going to be running arithmetic operations, and then you can just put an L here, and that will tell R that this is definitely an integer and you want to store it as an integer. All right, we've done 2. We've got 3 more to go. Okay, so what's the next one? The next one is complex. We won't be stopping on complex for too long, but because it is a data type in R, I thought it's worth mentioning. So let's say 3 plus 2i. So if you've done math, like a bit sophisticated math, then you'll know what complex numbers are. If you don't really worry about it. We won't be dealing with them. I'm just going to show you how they work here. So a z is a complex number. It's 3 plus 2i, and if you want to check type of a z, you'll see that it is indeed complex. All right, once again, we won't be stopping that for too long, so let's move on to the remaining 2. The remaining 2 are character. That's number 1, and let's create a character. So we're going to call this variable, I'm going to make some more space here, and we're going to call this variable a. And inside a, we want to put some text, or let's say we want to put a letter. We're going to put the letter H. So to put a letter into a variable, you need to put quotation marks. And as you could see, so I'm going to redo that again. As you can see, as soon as I press the single quotation, press the double quotations symbol once, RStudio conveniently creates a second one for me, so I won't forget to close my quotation marks, and then I can put a letter inside here. And as you can see, it's been highlighted in a different color. And now I can check type of A, right? So what you'll see is if I just run type of A right now, I'll get an error. Type of A, object A not found. And that's because I haven't created this variable yet here, so you can't even see it here because I forgot to run this line. That is because R will only execute the lines that you tell it to run. So first, let's run this line, and now we can check type of A. As you can see, it is a character. All right, so that's how you basically store any kind of letters, text, and so on. And finally, we're coming to the last data type that we'll be looking at, and that is logical. So in order to create a logical variable, let's first give it a name. Let's say it'll be Q. That'll be the name of our variable. By the way, you don't have to limit yourself at just one letter for the variable. So let's say it'll be Q1, for instance. And here we'll assign it a value of true. So logical variables are basically either true or false. And here we're going to assign a value of true. And for true, we'll just use the letter T. And now we'll type of Q1. First, we'll run this line. And as you can see, now we have a variable here, true. And now we'll run this line. As you can see, it's logical. By the way, there are other ways you can create logical variables. So for instance, you could say Q2 is not true. So you can do true, or you can do F, or you can type in the whole world, but it has to be in caps. So Q2 is false. And now we'll be type of Q2. Let's check that as well. It's also logical. So that's how you create logical variables. Alright, so that brings us to the end of today's tutorial. Hope you enjoyed it. Have a play around with that. Try experimenting, creating your own couple of variables just to make sure you understand how the different types work. And I look forward to seeing you next time. Until then, happy coding. Hello and welcome back to your course on R programming. How did you go with the previous tutorial? I hope you found it quite simple to create variables in R, and if so, congratulations, because this is the goal of this course, to smoothen out that very steep learning curve that R normally has and that students are normally presented with when they're starting their journey into R. Alright, now that we're comfortable with creating variables, today we will learn how to use them in different operations, varying from arithmetic operations to even calling functions. But don't be afraid, once again, everything is step by step, so we will learn just the right amount that we can handle in one tutorial. Alright. First things first, we need to save this file, because it's always a good skill to have to know how to save the work you have done. So how do we save this file that we've created here with our code? Well, it's pretty simple. If you're on a Mac, then press Command S. If you're on a Windows PC, then press Control S, or otherwise just click this save button up at the top over here. So I'm going to press Command S, and here you just have to specify the name of your file. So I'll call it tutorial01 and click save. There we go. That is our file saved. And now we're just going to create a new one by clicking the RScript button over here, like we did last time. And now we see a blank worksheet over here. What we see here is in the global environment, we still have our variables that we created last time. Let's clean them up. Now there's a lot of ways to do it, but we'll stick to the basic one. We'll just click this broom over here and say yes, and that will delete everything. And lastly, we've just got some code in the console, and that's fine. Let's leave it there. It will disappear as we create more code. It will scroll up and out of our visibility. All right, so let's start off by creating a variable. We're going to create a variable called a, and we'll put the value 10 into this variable. So let's type that code and run it. By the way, I hope you're following along, because it's very important to follow along and do the exact same steps on your computer, because that way you will learn R much faster than if you're just watching it. So follow along and let's create a new variable. This time we'll create a variable called b, and we'll put in the value 5. Execute. And as we can see, we're already used to this. The code has been copied into the console and it has been executed over here. So we've got the variable. All right, so let's say we want to add these two variables and put the result into a third variable, which is c. Let's go ahead and do that. So here we go. There is the variable c, and we will assign it the value of a plus b. Very intuitive. So hit return or run. And as you can see, the code has been copied into the console and we've got the result over here. Now, first off, what I wanted to point out is that spaces in R don't matter, as in many or most programming languages. So basically, I can remove these two spaces, rerun the code, and it will run just fine. The variable has been overridden. It's still 15. That is because spaces, RStudio ignores spaces, and they're basically there for your aesthetics. Now, the second thing was, how do we print out this variable? We know that the value of c is 15 because we see it here. But let's say we don't have access to what's going on in here. Then all we're left with is the console, and we can't see the value of c in here. We just see that this operation has gone through. How do we see the value of c? So in other programming languages, you might have to use a function like print or printf or alert or other sorts of functions. In R, it's very simple. All you have to do is just print the object's name. So in this case, we'll just type in C and execute this line. And there we go. We've got the value 15. It has been printed out over here. So that is how easy it is to get objects to display on your screen in R. Just basically print the name of the objects and execute that line. All right, let's move on. Let's create another variable. So this time we'll give it a bit of a longer name. We'll call it variable 1, so var1, and we will assign it the value of 2.5. And before we execute that code, let's create a second variable right away. Let's prepare the code for a second variable, variable 2, and we'll assign it the value of 4. Now, the other trick I wanted to show you here was that in R, you don't have to necessarily execute all of your code line by line like we've been doing up to now. So as you can see, the carriage return is here. So if I just hit run right now, then all that will be executed is just this line of code. But in R, you can actually highlight the elements of code that you want to execute. So in this case, let's say I want to execute these two lines at the same time, or not at the same time. They'll of course be executed one after the other, but I will want to execute them together. So in this case, I highlight them and I hit run. And as you can see, both lines have been copied into the console and both lines have been executed. We've got two new variables, variable 1 and variable 2. So that's how in R you can execute bits of your code. And now actually it makes much more sense why we have comments. So if I wanted to put comments to this code, let's say I would say variable 1 here, and here I would say variable 2. Because of these hashtags, R knows that these are comments now. And if I were to execute this code, including the comments, then even though they're copied into the console, R knows that it should ignore these two lines because they have hashtags at the start. So R will actually only perform operations based on these two lines that we actually want. So that is how you execute multiple lines, and that's how comments tie into this whole coding in R exercise. All right, so we're done with the variable 1 and variable 2. Now let's do some operations with them. Let's say we want to find out what the result of their division will be. So result of variable 1 divided by variable 2, and let's run that line. And now let's just print out result. So as you can see, it's 0.625. All right, so let's run one more. I wanted to show you that not only you can perform operations with variables and include multiple variables in those operations, but you can actually call functions and pass values to those functions, which are your variables. Let's say I want to find out what the square root of variable 2 is. Variable 2 here is 4. So I would type in answer is sqrt variable 2. Now here in this case, sqrt is a function, and the brackets indicate that the values inside are being passed on to this function. Now, don't be worried if functions seem a bit of like a gray area to you right now. That's totally fine. We're not going to dive deep into them now. We'll discuss them in a lot of detail further down in this course. What I wanted to show you here was just to illustrate that variables can be used in many different ways, including as arguments for functions. So in this case, let's run this line, and now let's print out our answer. As you can see, it is 2, which is correct. All right, so those are our arithmetic operations. And of course, that's not the limit. You can not only add and divide, you can multiply, you can subtract, you can get square roots, you can basically do any operation in R that you could think of on your simple calculator or even a complex calculator. But now what we're going to do is we're going to move on to character operations and see how we can work with some character variables, just to illustrate that that is also possible in R. So let's start by creating a variable called greeting. And into this variable, we'll put the word hello. So as you remember, you have to use quotation marks to tell R that you're creating a character. And then we'll create a variable called name. And into this variable, we'll put the word Bob. So we want to create a message for Bob. So let's add some lines. And we want to create a message. And we want to say, hello, Bob. So how do we add these two variables together? Well, in R, the function for adding two strings together is called paste. And to that function, we're going to pass the first variable, which is greeting over here. And we're going to pass the second variable, which is a name over here. And if we execute this, oh, once again, we got the error because I did not execute these lines. So how about we run all of these three together? So if we execute all of these three, you can see that first one executes, second and third. And now we can simply print out message over here. As you can see, we've got hello, Bob. All right, so that's how we create and work with character variables as well. And once again, we use the function here. Don't worry if it seems a bit complicated. We will talk much more about functions further down in this course. Okay, so that is us for today. I would like to invite you to practice with these variables and see what other operations you can think of. So try multiplying, try subtracting, try, for instance, maybe including not just two variables, but 3, 4, maybe 5 variables in one operation, and see what you get. Because remember, practice makes perfect, and that is the best way to learn a new programming language. And I look forward to seeing you next time. And until then, happy coding. Hello and welcome back to a course on R programming. Today we'll talk about logical variables and operators. Let's dive straight into it. First off, we're going to save the file for our previous project. So once again, we're going to press Command S or Control S, depends on what machine you're on, and we will give it a name, tutorial 02, and just go ahead and click Save. And now let's create a new script. Once again, we will clean up the environment, click yes, and let's get straight into logical operators. So logical operators can basically have two possible values, and we've actually already talked about these, so let's put a comment in. And what are the possible values that they can have? They can either be true or they can be false, and it's important that it's all caps. And also you can use just the word, just the letter T or just the letter F, but also it has to be caps. So what is a logical operator? Well, let's have a look at a couple of examples. Let's say we want to check if 4 is less than 5. Then we type in 4 less than 5 and we run this line of code. What we get in result is the word true, meaning that R is telling us that the result of this operation is true. And that is because this operator over here, less than, is comparing the two numbers, 4 and 5. Let's do another one. Let's check that if 10 is greater than 100. Let's run that. And what we can see here is this line has been copied, it has been executed, and as you can see, it's false, which is correct. 10 is not greater than 100. Let's check another one. Let's see if 4 is equal to 5. And let's run this line of code. Once again, we get false because 4 is not equal to 5. So these are examples of us using logical operators less than, equal, greater than, or equal to. In R, there are actually quite a few logical operators, and we will be looking at 10 of them. Let's list them out here. So the first one was is equal to, second one is not equal to, so that's how you write it, an exclamation mark and then an equal sign. And also be careful that in the equal to operator you have to use the double equation sign, because in some programming languages a single equation is sufficient. Then we've got the less than, we've got the greater than, we've got the less than or equal to, greater than or equal to, then we've got the simple not, and I'll show you how to use that one in a second. Then we've got the or, so in some languages you need the double vertical line like that. In R you have to be careful that you use only the single one, because the double one will work, but it has a completely different meaning. And also you've got the single and for and then one more, which is a function to check if something is true, and it's is true, and then you put the variable inside there. So let's have a look at a couple more. So let's say I want to check if 4 is less than 5, which we've already done, but I don't want to just print the result as we've been doing. I want to store it in a variable. Now, as you can see, our environment is empty here, so we don't have any variables because we've been just printing the results so far. So how about we put this result into a variable, and we'll call this variable result. We know the assignment operator, so what you can see is happening here is we're checking this, and then the result of this operation is going to be stored in the result variable. Let's go ahead and run this line. There we go. As you can see, this line has been executed and no value has been printed out because we haven't asked for that. And what we got is a variable with the value true, which we can now just simply print out and check its value. There we go. It is true. Okay, so let's make some more space. And now for curiosity purposes, let's check the type of result, which we know how to do from the first tutorial. If we run this, we will see that a result is a logical variable, which is a type of variables which we are familiar with already. And makes sense, right? If it's a logical operator, then the result of that would be stored in a logical variable. All right, so now let's see how we can use the not operator. So this interesting one that we saw over here. Let's say we have a new variable, result2, very creative, Kirill. But anyway, result2, and we want to use the not operator, so we'll say not true. So basically, not is an operator which is applied to anything that goes after it. In this case, it's the word true. So if we run that, now we have inside result2, we have false. And you could have replaced this result true with any kind of other operation or variable. So for instance, here I could have said is 5 greater than 1. Or run this line, and now if I check result 2, you'll see that it's false. So basically this is true, and then when you put the exclamation mark behind it, before it, what you get is the opposite of whatever is here. Whether it's true, it'll be false, or if it's false, it'll become true. So there we go. So in result 2, we have false now. Okay, and finally, let's get to these two. So the or and the and. So let's see what happens if we say result, which we know is true, or result 2. So basically, we're saying one of these has to be true. At least one of these has to be true. So either this one or this one. And let's see what happens if we run that. If we run that, we get true, because we know that this is true, this is false, but true or false gives true. Now, if we run result and result 2, now we are requiring, by specifying this operator here, we're requiring that both of them are true. Otherwise, so the only case in which this will return true is if both of them are true. In our case, one of them is false, so if we run this, we'll get false. And there you go. That's how these work. The last one is true. All we have to do is type in is true and then put the value that we want to check inside here. So let's say we want to check the value of the variable result, right? Is it true? Yes, it is true. The answer to this question is true. All right, so that's how logical operators work, and that is how we can use logical variables to store results of logical operators. Have a play around with that. This will come in handy throughout this whole course whenever we're working with loops or if statements, or whenever we're checking matrices or vectors for a certain criteria, so when we're filtering our data and so on. So definitely get a grip around that, because you will need it further down in the course. And I look forward to seeing you next time. Until then, happy coding.